Good morning, everyone. I'm Uma Maheshwari, Assistant Professor, Department of Electronics and Communication Engineering. In this video lecture series, I'm going to explain about MAC protocols in wireless communication. It is nothing but the medium access protocol, which is the first protocol layer which is present above the physical layer. The fundamental task of any MAC protocol is to regulate the access of number of nodes to a shared medium in such a way that certain application dependent performance requirements are satisfied. This is the simple diagram of a medium access control protocol. So the next one is fundamentals of MAC protocols, requirements and design constraints for wireless MAC protocols, then important classes of MAC protocols, then MAC protocols for wireless sensor networks. So the requirements and design constraints for this wireless MAC protocol are uh, uh, the throughput efficiency, stability, fairness, low access delay, and a low transmission delay as well as the low overhead. So the overhead of MAC protocols are it should be per the packet overhead, collision multiple sender wants to talk. Collisions can happen if the MAC protocol allows two or more nodes to send packets at the same time. So the next one is hidden terminal problem. The hidden terminal problem occurs specifically for the class of carrier sends multiple access protocols where a node senses the medium before starting to transmit a packet. Exposed terminal scenario. In wireless networks, when a node is prevented from sending packets to other nodes because of a neighboring transmitter is known as the exposed node problem. Hidden and exposed terminal problem, where B is a hidden terminal to A and A is an exposed terminal for C as per the below given diagram. The next one is the hidden terminals where A sends to B, C cannot receive A. C wants to send B, C sends a free medium. Collisions at B where A cannot receive the collision, where A is hidden for C. So in exposed terminals, B sends to A, C wants to send another terminal. So C has to wait, C signals a medium in use, but A is outside the radio range of C. Therefore, waiting is not necessary. That's why C is exposed to B. So the near and the far terminal problem. Terminals A, B and C, where A and B sends, C receives. Signal strength decreases proportional to the square of the distance. The signal of a terminal B therefore drowns out A signal. C cannot receive A. A huge number of MAC protocols have been devised during the last 30 years. They can be roughly classified into the following classes: fixed assignment protocols, demand assignment protocols, and the random access protocols. Whereas in fixed assignment protocols, each communicating node is assigned a frequency band in FDA systems or a time slot in a TDMA systems. Next one is a demand assignment protocol, where demand assigned multiple access is a protocol which is used in satellite communications, particularly very small aperture terminal systems. So the next one is random access protocols. In random access or contention methods, no station is superior to another station and none is assigned the control over another. So the transmission is random among the stations. That is why these methods are called the random access. So the MAC protocols which is used for wireless sensor networks are balance of requirements, energy problems of the MAC layer, where various energy problems are represented in this small diagram shown below. So the requirements are it is different from traditional wireless networks. So additional requirements come up first and foremost the need to conserve energy. The important requirements of these protocols are scalability. The need of scalability that should be evident. Then when considering very dense sensor networks with dozens or hundreds of nodes in a mutual range. These are the energy problems in the MAC layer. The first one is collision, next one is overhearing, the next one is a protocol overload, and the next one is ideal listening. Collision is nothing but multiple senders want to talk. Overhearing, it is nothing but to hear a packet and drop it when it is not destined to them. So these nodes overhear the packet. Protocol overload, where RTS and CTS packets are request packets in demand assessment protocols, and therefore uh, this packet headers and the trailers. Then ideal listening, active listening to a redundant channel. So list the classification of a MAC protocol and what is meant by the hidden and the exposed terminal. Thank you.